Thank you to Draper and its Hack the Moon initiative for supporting PBS Digital Studios. For much of human history, people believed that the planet Earth was the centre of the universe. That's understandable. Earth is pretty big. We now know that it's a speck compared to the universe. To get a sense of that scale, consider this grain of sand held at arm's length. In that tiny area, there are almost 10,000 entire galaxies. That's a quadrillion stars and as many planetary systems. In fact, there are surely more entire worlds in the observable universe than there are grains of sand on this one. Less than a century ago, we didn't know that a universe existed beyond our own Milky Way galaxy. In the last 100 years, our perspective and our understanding has grown enormously to include countless galaxies to the cosmic horizon and almost to the beginning of time. But before we could map the universe, first we had to discover the universe. We're at the Mount Wilson Observatory on the outskirts of Los Angeles, California. This is where Edwin Hubble made a paradigm-shifting discovery. In 1924, he proved that the universe exists beyond the Milky Way. Oh my God, this is the Hooker telescope at Mount Wilson Observatory. It is beautiful. The whole dome is built of Carnegie iron. In the years when most of the iron was being sent to the front for tanks, this thing was built in 1914. That's not to say we'd never seen other galaxies. Andromeda is visible to the naked eye if you have good vision. And many nearby galaxies were visible as fuzzy blobs in our early telescopes. But as far as we knew, they were just clouds of gas inside our own galaxy. The philosopher Immanuel Kant guessed that these nebulae might be entire island universes of their own. In 1915, the American astronomer Vesto Sliter reported that some of those fuzzy blobs were zipping away from us so quickly that they would surely escape the Milky Way's gravitational field. It was a clue that they were, in fact, never within the Milky Way in the first place. But to prove that these spiral nebulae were really island universes, we needed to find their distances. And distance is one of the hardest things to measure in astronomy. So that's the desk and chair where Edwin Hubble conducted his observations of Andromeda to calculate its distance. He would spend nights up there taking photographs, sensitive photographic plates, using a camera much like this one. Photographic plates go right in here. See, when you look through a telescope, it flattens 3D space into a two-dimensional image, a dome above our heads that the ancients called the celestial sphere. All sense of distance is lost. For example, consider two stars, one bright and one dim to our eyes. Now, perhaps those stars are identical and the bright one is just closer to us. Or perhaps the bright one is truly much more luminous and is at the same distance or even further away than the dim star. Now, there are some clever ways to measure distances to stars when they're within the Milky Way galaxy. But in another galaxy, not likely. At least not until the brilliant work of astronomer Henrietta Leavitt. A decade before Hubble made his discovery, Leavitt discovered that a certain type of star, Cepheid variables, brightened and dimmed with a repeating period that is mathematically related to the star's absolute brightness. They were the first standard candles. If you time how many days or weeks it took a given Cepheid to fluctuate, you can determine its true brightness. So, you can also figure out how far away it is just by seeing how much its true brightness has been dimmed by that distance. That means if you spot a Cepheid variable in a distant spiral nebula, you can find the distance to both. And that's exactly what Hubble did. Right here, he looked for Cepheid variables in the Great Andromeda Nebula, as it was known back then. He found that Andromeda is around 2 million light years away, or around 20 times the entire diameter of the Milky Way disk. The Andromeda Nebula became the Andromeda Galaxy. And with more distance measurements, it became clear that all spiral nebulae were island universes of their own. Of course, Hubble didn't stop there. He combined his distances with Vesto Sliter's velocities to discover that the galaxies all appear to be racing away from the Milky Way. paving the way for the discovery that the universe is expanding, meaning it must once have started with the Big Bang. With this telescope, Edwin Hubble not only discovered the universe beyond the Milky Way, but he opened the door to discovering its very origin and to our exploration of the true vastness of the universe that followed. To see where nearly 100 years of exploration has led us, we'll need a little help from the digital universe built by the Hayden Planetarium at the American Museum of Natural History. We're on our way up. This is where it all happens. What of you? We're looking down at the planetarium from the astrophysics department. FYI, this is pretty much my favourite place in the world, and I spend as much time here as I can. Folk here at the Hayden have turned that dome into a spaceship. It can fly us through a virtual universe built from the most complete 3D atlas of our universe ever compiled. And unlike regular spaceships, this dome can fly at many times the speed of light. It's the perfect place to explore the scale of the vast universe that Edwin Hubble unlocked for us. Let's take a journey. We're now flying through the American Museum of Natural History's digital universe, rendered by the OpenSpace software. Leaving Earth, the Sun, and our solar system behind, we're zipping past the hundreds of billions of stars of our Milky Way galaxy at a few hundred billion times the speed of light. While we've only mapped the locations and velocities of around 1% of those stars, that gives us an incredible understanding of the shape and motion of our home galaxy, once imagined to be the entire universe, and now our very familiar island home. As we zoom out, now to several trillion times the speed of light, our local group of galaxies comes into view. There's Andromeda, its incredible distance first revealed to Hubble through its pulsing Cepheid variable stars. That's the Virgo cluster, the nearest big city, of which our local group is an outlying suburb. Every dot we see is a known galaxy, its position, velocity, and even stellar content measured and catalogued. The latest studies of galaxy motion reveal that Virgo, the Milky Way, and 100,000 more galaxies belong to Laniakea, a cluster of superclusters some 500 million light-years across. As we accelerate to 100 quadrillion times the speed of light, we see the extent of our modern mapping of the universe. Galaxies assembled into many vast filaments, flowing together on rivers of dark matter to form the cosmic web, of which Laniakea is just a part. Edwin Hubble never imagined such a structure. Those smaller dots at the edge of our surveys are quasars.
We humans are driven by the desire for knowledge. The ability to understand the workings and structure of our environment helped our species reach the highly developed point in our own history where we are today. Although humanity regularly produces new technological milestones, there are still countless realities that elude our knowledge almost entirely. While these mysteries of life on the one hand cause big question marks over the heads of experts, the fascination that emanates from these unsolved mysteries is equally undisputed. This topic becomes particularly exciting whenever we turn to a field that seems to exceed our tangible horizon. In the case of the universe, research is still in its infancy despite all the rockets sent into orbit and the successful moon landing in 1969. At present, we know only a tiny part of what is currently still hidden from our eyes in the infinite vastness of space. The question of how big the universe as a whole actually is a mystery that mankind has been dealing with for countless centuries. With today's contribution, we would like to present the current state of research on this topic. We will show you the current state of astronomical knowledge of our species, and we will also talk about why the answer to the question of the size of the universe is so difficult to come by. If you like our videos, please support us with a thumbs up, subscribe to Simply Space, and look forward to the videos that will be waiting for you in the future. Let's begin our journey through the vastness of the universe.
Behind the Apollo missions, brought to you by Draper. The site is full of images, videos, and stories about the people who hacked the moon. If the universe is so enormous, why haven't we seen other signs of life? If you want an answer to that, head over to
what we can see of the universe.
To watch Johansson
when we take a look at the sheer gigantic starry sky at night, many of us realize how small we ourselves are in relation to the big picture.
You the universe
the thousands of twinkling stars in the firmament bear silent witness to the fact that our small home planet is only a tiny part of what is